Hello, today I'm going to be talking about kinematics. Specifically, I'm going to talk about speed, velocity, acceleration, and motion. I would suggest that you go watch my previous two videos to get a detailed explanation of speed, acceleration, and velocity. In this video, I'm going to go straight into motion. And specifically, uniformly accelerated motion. So uniformly accelerated motion is known as a special case of constant acceleration. It's exhibited in very many examples in everyday life. Some equations that can be very helpful in solving for key variables describing motion are the following. So first we've got velocity is equal to velocity initial plus acceleration times time. Then we've got x, which is known as position, is equal to x initial, position initial, plus velocity initial times time, plus 1/2 acceleration times time squared. And then we've got velocity squared is equal to velocity initial squared plus 2 times acceleration times change in x, which is just the displacement, or also known as position final minus position initial. So now that we've got a basic idea of motion and some equations that we can use, I'm going to relate these to a real-world example from an AP exam multiple choice section. So this is a continuation of problems number 14 and 15. So again, I highly suggest that you go watch my previous two videos before you watch this one, because I'm going to be taking pieces from those videos or solutions from those problems and applying them into problem number 16. So what we are given in this problem is that a ball of mass 2.0 kilograms, I'm going to write small for this one so I can try and get as much all in one board, is thrown vertically upward from the top of a building. The ball's velocity is given as a function of time by the equation velocity is equal to r minus st. So we know r is equal to 5 meters per second, and we know that s is equal to 10 meters per second squared. The positive direction is upward. From problem number 14, we know that the ball's acceleration at time t equals 1 second is equal to negative 10 meters per second squared. And we also know that the ball is at max height when max height at t is equal to 0.5 seconds. So problem number 16 is asking us, if the ball reaches the ground at t equals 2.0 seconds, what is the height of the building? So I'm going to draw a little diagram so we can visualize this. Got our building here. This is the ground. The ball is thrown up, reaches its maximum height at t is equal to 0.5 seconds, and it reaches the ground at 2.0 seconds. Okay, the problem is asking us to find the height, this, okay? So we want to solve for this height, 1, and this height, 2, so we can subtract height 2 from height 1 to get height of the building. So I'm going to start with finding the initial velocity of the ball during the time period from 0 to 0.5 seconds, so that I can then apply that initial velocity into the equation of motion to get the displacement of the ball, which is also known as the height 1. So we know that velocity initial is going to be given by the acceleration times the time, which is also known as, okay, let's just write it like this so it's not confusing. Acceleration times time, we know that acceleration is 10 meters. Okay, velocity initial is equal to negative acceleration times time, which is equal to negative 10. Two negatives cancel out to become positive. So 10 times the time, which is 0.5 seconds, 10 times 0.5, which is equal to 5 meters per second. Now that we know what the initial velocity is, we can use the equation of motion, which is velocity squared equals velocity initial squared plus acceleration, 2 times acceleration, change in x times the displacement. So we know that velocity squared at the height is 0. We know that velocity initial, what we just solved, is 5. So 5 squared is 25. Plus 2 times the acceleration is 2 times negative 10 times change in x. Okay, we want to solve for change in x. So we subtract 25, divide by negative 20 on both sides. We get change in x is equal to 25 over 20, which is equal to 1.25, which is also known as, let's see, height 1. So we've officially solved for height 1 here. We've got 1.25 meters. 1.25 meters. So our next task is going to be solving for height 2. So we're going to be looking at the function from 0.5 seconds to 2.0 seconds. If we want to know how much time has elapsed between there, we do time is equal to time final, 2 seconds, minus time initial, which is 0.5, which equals 1.5 seconds. So we're going to be looking at the period of time over this 1.5 second interval. So now we're going to use the displacement equation, the position equation, which is x equals x initial plus velocity initial times time plus 1/2 acceleration time squared. So we know that the position initial is 0. We're starting at, Right, the initial position is 0 because we're essentially starting the function from here. Position initial is 0. The velocity initial is again 0 because the object is essentially falling from rest. Times 1.5 because that is the time elapsed. Plus 1/2 times the acceleration, which again is 10. Times 1.5 squared, which is the time squared. If you multiply it all out together, you will get 11.25 meters, which is also known as height 2. So now we know that height 2 is equal to 11.25 meters. Now we're trying to solve for h. So h is going to equal h2 minus h1. We know that h2 now is 11.25. We know that h1 is 1.25, which equals 10 meters. So now we know that the height of the building is 10 meters, which corresponds to option B on the exam. Thank you.